Hi students, I'm going to go ahead and do the 6.6 and 6.7 notes video together here today. So you're going to see both of those as I go through this, but they're both pretty quick. So in 6.6, it's called the triangle inequality, and it's all based on the triangle inequality theorem. So in order for three segments to form a triangle, a special relationship must exist among those lengths of the segments. The sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So if we think about a triangle, it's going to have, I'm going to call it a small, a medium, and a large side to it. Sometimes the small and medium might be equal to each other, medium, large might be equal to each other, whatever, but that's the idea. And so essentially what this says is that the small plus the medium, the sum of the lengths of any two sides of a triangle must be greater than the length of the third side, which would be the large side. Then you also know that the medium plus the large has to be greater than the small, and you know that the small plus the large has to be greater than the medium. Now, what this comes down to is that you actually only have to check this very first one as long as you understand that idea of small, medium, and large, because if the large side is already greater than the small side by itself, there's no reason to check those by themselves. And the same thing here. If the large side is already greater than the medium side, then we don't have to worry about that, okay? So we really only have to check this one right here to make sure that that works in each example. So in the check, is it possible to form a triangle with the given side lengths? If not, explain why not. Well, all you do here is you take the smallest plus the medium, so 2 plus 5, which is equal to 7, and show that 7 is greater than 6. So the answer here is yes, that all of the side lengths are, or the sum of two side lengths is greater than any other side length. And again, that's the only one you have to check. Down here, you do the same thing. You do 3 plus 4, which is equal to 7. 7 greater than 8 is what you're looking for. That is not true, so that is a no. We don't care that 7 is less than 8. We care that 7 is not greater than 8. Okay, so that's the idea there. And if it's 7 is greater than 7, if that's what it says, that is also not true. Okay, so to install a smart thermostat, Kelvin is cutting a triangular hole in the wall. He marks side lengths of 2 1/8 inch and 2 3/16 inches. Which assumption do you need to make to determine the range for the measure of the third side of the hole that is being created here? And so we want to just make sure we understand that the triangular hole is not equiangular. We don't have to make that assumption. The smart thermostat requires a triangular hole. We're doing the triangular hole in the wall. It doesn't have to require it, but that's what we're doing. And then Kelvin measured the side lengths accurately. This is what is the big deal, because if those aren't measured accurately, then we can't talk about the other side. Two sides of the hole are longer than the third side. It's not what is going on here. So what is the possible range for the third side length? What will you do to find the range? And so this is essentially given any two lengths, 2 1/8, 2 3/16. You don't know if those are the two smallest sides, and so you're trying to find the longest. Those could be the longest and the shortest, and you could find the medium, or those could be the two biggest, the longest and the medium, and so you could find the small. So essentially you're trying to figure this out. And so you really want to, because the medium would be included, you want to find the largest measure it could be and the smallest measure that it could be. And to give the range, you're actually finding the smallest measure it could not be. And so let's do that real quick. So all you do is you take 2 3/16 minus 2 1/8. And I would just make this into 16ths. So this would be 2/16. So 2 minus 2 is just 0. 3/16 minus 2/16 is 1/16. So that is the smallest measure it could possibly not be, is essentially what it is. So it couldn't be 1/16 because 1/16 plus 2 1/8 is equal to 2 3/16. But this is essentially that 1/16 measure that we put here. And then we find the largest. So we take 2 3/16 plus 2 1/8, or 2 2/16. And that's going to give me 4 5/16. And so that's going to be this measure here. And we said that it has to be between that. So we can either write it in words and we can say between, which means in the middle of, not including, 1/16 and 4 5/16. Or if we want to write it as an inequality, I can call this third side length x, and I can say that it's 1/16 is less than x, which is less than 4 5/16. So I'm essentially saying any value that is between those two things there. So one of those ways to write it is kind of what you're trying to do there. And how do you find it? You subtract the two values, you add the two values to find that smallest and largest possible length. Okay, so then that takes us to 6/7. So 6/7 is over inequalities in two triangles. So we're looking at two triangles here, and we're going to get into the hinge theorem. So the very first theorem that's shown here is the hinge theorem. It says if two sides of a triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second triangle, then the third side of the first triangle is longer than the third side of the second triangle. So two sides of a triangle are congruent to two sides of another triangle. So if we kind of give ourselves a picture here, okay, we have two sides of a triangle are congruent to two sides of another triangle. So there's my two sides, okay? And the included angle of the first, so this one, my included angle here of the first is larger than the included angle of the second. Here's my included angle of my second, and this is smaller, so larger and smaller. Then it's saying that then the third side of the first triangle, so the third side of the first triangle, that'd be this one over here, is longer than the third side of the second triangle. So think about that for a second. If I were to make a triangle and have this distance here, and I have like this distance here or whatever, and same thing over here, I have this one and I have that one, and I make these the same measurement. So that's my start to my triangle. And I show that this is, let's say this is 100 degrees, and that this is going to be 60 degrees. Then when I connect this third side wherever I connect it, then this side is going to be longer and this side is going to be shorter. That's what that is telling us there. Okay. So for the check, Esperanza and Landon each fly a drone from the same place in a park and at the same altitude. So we've got a place here. Esperanza flies her drone 440 feet east. So we have 440 feet east, which is right, then turns at 120 degrees south of east. So south of east, from this point here, east would be this way. South of east would be this way. So we're going to go, I'm trying to picture this, 122 degrees this way, okay, and flies 300 more meters. So we're going to go 300 more meters here, if we can follow that idea. So this is where Esperanza's drone is ending up at. And then we are going to, again, from this starting place here, Landon flies his drone 440 feet east. So we're going to go on that same measurement there, 440 feet east. Then turns at 140 degrees north of east. So there's my east. North is this way, and I'm going 140 degrees. So I'm going to do something like that. I'm going to go 140 degrees north of east and flies 300 more feet. So this is also 300. And so we're trying to figure out whose drone is closer to the original position. So this would be Landon right here. And we can finish this off with a triangle to where we would have Landon's distance and Esperanza's distance. And if this is 122, I'm going to do 180 minus the 122. Which is going to give me 58 degrees. So this is 58 degrees. And then I'm going to do the 180 minus the 140, which is going to give me 40 degrees. That's this right here. So since these two sides are congruent and these two sides are congruent, then the included angle determines the bigger. So this one is smaller, this one is bigger because that's the angle measure. It says whose drone is closer to its original position. So if this angle measure is bigger, then this distance is bigger. And this distance is smaller. So closest to would be Landon. So Landon would be closest to the original position that is there. Again, I tried to talk you through that one so that you understood that idea. The converse of the hinge theorem says that if two sides of a triangle are congruent to two sides of another triangle, so let's do our due diligence here again. So we have this congruent to this and this congruent to this. And the third side of the first triangle is longer than the third side of the second triangle. So we know that this is larger and this is smaller. Then the included angle measure of the first triangle, so this one right here, is bigger than the included angle of the second one. This one is smaller. Okay, so that's what it's doing here. So instead of knowing the angles and saying the sides, we know the sides and we can talk about the angles that are in there. So find the range of possible values for x. So if we look at our problem here, we can figure out that we have this congruent side, and then we have this other set of sides that are congruent. So we have those two sets that are congruent. So since 19 is bigger, this angle has to be the bigger angle, and this one has to be smaller. So what we know then is we know that 3x plus 10 has to be smaller than 55. Can't be equal. If these two were equal, then those two angles would be equal. But we have it less than. So I'm going to subtract 10. I'm going to get that 3x is less than 45, and I'm going to divide by 3 to get that x has to be less than 15. So for the range, usually you have one side and the other, so x has to be less than 15. But you also know that this angle, for it to be an angle, that 3x plus 10 has to be greater than 0. So we can solve with that and subtract 10 and get that 3x is greater than negative 10. And we divide by 3, and therefore x is greater than negative 10 thirds. So x is greater than negative 10 thirds, or negative 10 thirds is less than x is what I've put into there. So that's the range. Now there's a few different things that'll come into problems like that, so we'll talk about them as we go. But you really just want to think about what you know about triangles. Sometimes it's that the angles all have to add up to 180, or that an angle can't be bigger than 180, and just kind of different things like that. Okay, that's it.